Here we go. Okay, so if I had used the book's definition of the unit circle, the book has a definition that looks something like this, like the image of the point 1 comma 0 under a reflection of something. And all that means is like, if we take, oh, my pen's not working too well. That point 1 comma 0, which is like kind of always our starting place, and rotate it by some amount, that's what gives us the unit circle. So that's all this crazy sentence is talking about, is we're starting here and we're rotating. This tells me to rotate by 75 degrees. So 75 degrees is going to be like here-ish somewhere. And then we just need to come up with the coordinates for that. So these aren't going to be exact values because 75 isn't one of those angles that's like on your unit circle for the exact values. But how do we find any like coordinates on the circle? It's always the what and the what of the angle.
The cosine and sine.
There you go, cosine and sine. So yeah, so all I'm doing to find this point here is I'm doing the cosine of 75, and that's just in your calculator. And then the sine of 75, and just writing them down as a coordinate. So I'm gonna do like, let's see, cosine 75, sine 75, and I think it told me to go to the nearest thousand. So that'd be 3 places. So this would be 0.259. And then 0.966. So really the point of that question was just that you can find coordinates anywhere on the circle by doing the cosine and the sine of that angle. I think the way they just worded this part threw everybody off, but that's what they wanted you to do. Okay. I'm sorry, guys.
So
I get weird.
Yeah. So then could you take that and then on 10.5, I think it's number like 13.
Yes.
Or that,
like 13 through 16, right?
Yeah.
Yeah.
Is that kind of the same thing you would do for those?
Exactly. So like if this is 100 degrees, you could get the coordinates of A by doing cosine 100, sine 100, and then those just fall into these 2 spots here. So anywhere you see X coordinate, that'd be cosine, and anywhere you see Y coordinate, that'd be sine.
Okay.
Yeah, good question. What else on 10.5 can I do for you?
23 and 24.
Yeah, those are hard ones. I was expecting those. Okay, let's do 21 and 22 before we tackle 23, 24, because we're going to need those to do these. So if I want the cosine of this, by the way, is called an alpha, and it's just like another Greek letter. We use it kind of like theta. We use it like a variable, but we use it when we're talking about angle measures. So when I say cosine alpha, like this one is marked alpha, I just have to figure out which one of these 2 is the cosine. Which one is the cosine in a coordinate?
The first one.
The X.
There you go. Yeah. So
Yeah,
that's my cosine. So I'm going to go negative 0.391 here. So then for sine of theta, here's my theta angle. This would be cosine, this would be sine. So I'm going to do negative 0.970. Do you guys figure out those 2 okay?
Mm-hmm.
Okay. We just had to have those to do the other ones. So then like these questions are really just asking what the angle measure is. What is the actual measure of this angle here? And what is the actual measure of this angle? So if I tell you that cosine of alpha is equal to negative 0.391, like if I had given you that sentence right there, what would you have done to find the angle?
Oh, the inverse.
There you go, the inverse, yep. So I could do the inverse cosine of, what was that number? Negative 0.391. And that'll tell me what that angle measure is. It's 113 degrees. And this is important, and you're going to see more on the next question why it's important. It's important to take that angle measure and look at your picture and make sure that it makes sense, because there's something a little weird that happens here. But 113 degrees, I think that looks reasonable, right? So I would say that alpha is 113 degrees. Okay. So we should be able to follow that same reasoning, right? Like if we have sine theta equals this, we should be able to do inverse sine of theta and get the theta value. So I'm going to do inverse sine of negative 0.970. So first of all, it gives us this negative angle, and that's even okay. I mean, it just means that it's like down this way, right? That it goes this way. But the problem is, that's like negative 76 degrees. Negative 76 isn't even all the way to 90. Negative 76 would be like right here, right?
Mm-hmm.
So that doesn't line up with this angle, okay? And here's why. And we haven't really gotten into this. This is going to be a big topic in Algebra 2. And this question, they kind of sneak in here at the end of the lesson master just to see like if you're thinking about it, but I wouldn't worry about it as far as like a quiz or anything like that. When you say like the sine of this angle, doesn't it make sense that this angle and this angle are both going to have the same sine because they're both going to have the same like y value, right? So when you ask your calculator what angle has this as a sine, it gives you one possible answer, but there are actually two answers. So like this one, we used the cosine, so that's why that one worked out okay. But if we had used the sine value, it would have given us an angle that was over here on this side because these both have the same like y coordinate here, okay? And on this one, we could give it a try with the cosine, but I believe that's going to give us like this angle that's up here instead. So here's what we have to do. We have to say, okay, so negative 76 degrees means it's 76 degrees this way. But we know we're actually talking about this angle that's like 76 degrees this way, right? That we want to go 76 degrees from 180. So what I would do is take that 76, positive 76, and add it to 180 to figure out where that angle should be located, okay? And so this is really like a 256 degree angle. And if you wanted to check it and make sure, you could do cosine of 256 and you're going to get that decimal, right? That negative 0.242. You could do the sine of it and you're going to get negative 0.970. But that is a really, really tough one. Like I said, that's something you're going to be exploring a lot in Algebra 2. They kind of just snuck it in there on the end of the lesson master. So I wouldn't stress about that one too much. So number 12 says sine of 11 pi. Okay. And I think there's a couple different ways you could do this one. This one's not going to be too bad because it's just counting by pies, but some of these get really gross. Okay. So we know that this is 0, this is pi, and this is 2 pi all the way around, right? So if I'm counting by pi, I'm like jumping by half a circle. So if I want to find where 11 pi is, I'm going to go, here's 1 pi, here's 2 pi. If I keep going, this would be 3 pi, right? 4 pi. Now you may be able to figure out just by looking at that, like where 11 pi is going to end up, like kind of just looking at evens and odds. But if you had to, you could like literally count your way all the way around. So here's 4 pi. 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi. So 11 pi is really equivalent to just 1 pi, okay? If we're at 11 pi, if we're here, what are the coordinates at this point right here? Negative 1, 0.
Yeah.
Yep. And then this one wanted the sine, so that would be the 0. So I would say sine of 11 pi equals 0. Does that make sense?
Mm-hmm.
Okay, others from that mixed review at all?
Can you do like, is 16 kind of the same as that? Or
Yeah,
it's like, I don't know, 16 is weird.
16 is weird. Yeah, let's talk 16. So 16 is tangent of negative 6 pi. Okay, so negative 6 pi, we're going to kind of treat the same way, except we're going to go backwards around the circle, which again, doesn't really matter when you're talking like by pies, right? Because you're still landing in the same two places. But if it were any other angle, it would really matter. So -6 pi, I'm going to go backwards, and I'm going to go -1, -2, -3, -4, -5, -6. So -6 pi is really just the same as like 0 or 2 pi. Okay. Coordinates there are 1 and 0. Do you remember how to find the tangent if you've got the coordinates like that?
Is it sine divided by cosine?
That's it, sine over cosine. So I'm going to do 0 over 1, which is just 0. So the question says, is the tangent positive, negative, or 0? It would be 0. Oh, sorry, you can't see that, but it would be 0. Okay. Any others?
Can you do number 11?
Yep. Okay. So 11, I'll just keep using the same picture here, is cosine of -2 pi over 3. All right, let me grab a different color. Okay. Can you visualize where pi over 3 would be? Like when we're counting by pi over 3s, that's like 60 degrees-ish. And I know we didn't really talk about the converting. That's one of the things we usually do is convert between like radians and degrees. But pi over 3 is like the 60 degrees. So it would be here, here, and here. And then if I kept going, it would be here, here, and here. Okay, so those are your pi over 3s. 1 pi over 3, 2 pi over 3, 3 pi over 3, and so on. So if I want -2 pi over 3, negative means I'm going backwards, and I'm going to count 2 of those. So here's -1 pi over 3. Here's -2 pi over 3. And then I need to figure out the coordinates right there. Now, depending on how you have them memorized or how you kind of work through this, you may need to like fill in these coordinates up here and then kind of transfer them around. I always look at it as like, I picture that triangle in there. And this is my short side, which I know is 1/2. And this is my long side, which is square root of 3 over 2. And both of these are negative, right? Because it's going left and then down. So I know that my coordinates would be -1/2 and negative square root of 3 over 2. You follow that okay? I lose anyone there? Okay. So then if I want the cosine is the -1/2. Good with that?